go from current slide. Okay. Now, don't know of too many major announcements. I'm sure there must be some, but I'm a bit behind on emails. In fact, I'm going to be a bit behind on everything because we're trying to work on fall schedule, and it is one big mess. I mean, it's terrible. It's not too terrible for Patel to be here, though. So, here we go. So I'm going to be stuck doing that for a good bit of my office hours until we get it finished. They did something completely wacko last fall, and of course that's what we have to build on for this time. Quiz? Oh, it's way too late. No, I'm just kidding. If I can find it here. Here. Well, let's call them in through calculus true. No wonder I can't find it. You need graph paper? You don't. Okay. But, like I said, I'm sure there's plenty of announcements out there missing because I've been along. Only checking emails for what's immediate and haven't been doing a great job of keeping up with what's current with everything. But, research papers. I'm guessing a bit fewer than half the classes turn them in. And we have just a couple weeks left in the term, which means you only have maybe a couple weekends left in the term. If that's when you're going to work on a paper, please get going on it. First quiz. 1, 2, 3, 4, 5, 6 people haven't turned that in. Okay? That means at least those 6 haven't done the first test, and several others, 1, 2, 3, 4, 5, 6, 7, either have not completed the first test or haven't done it either. Okay? We don't have much time left, folks. Please get these done. Arrange with me to do it. Okay, quiz 2. I just gave one person 1. And again, fewer than half of you have turned those in, but several have, so that's good. And the second test is coming up very soon. So, let's get those things in as soon as you can. All right, we're in Chapter 2, which is polynomial and rational functions. We're finally through with polynomial functions for now, and now into rational functions, which is what 2.6 is. We got this started last time. We had a very abbreviated class. Sorry about that. But we got to this one, okay? Now, for those who weren't here, which is most of you who were not here, let's just talk about what we mean by vertical and horizontal asymptotes. Okay. Short. I don't do anything short. But just a brief review on this. A rational function is one that is a ratio of 2 polynomial functions. Ratio meaning division. That puts a polynomial in the denominator. Now, if that polynomial can ever be 0, the one that's in the denominator, for any value of x that makes that polynomial 0, you can't do it because you can never divide by 0. For instance, this one right here, the denominator is x plus 1. X plus 1 cannot equal 0. Well, where does that happen? When x is equal to negative 1. So x can never be negative 1. That means that's your vertical asymptote. X equal negative 1 would be this vertical line right here. This function cannot touch it, cannot cross it, can't go there, okay? That's why I put a dotted red line. The book does too. Now, horizontal asymptote. Horizontal asymptotes can be touched across by the function, but what a horizontal asymptote is telling you what's going on in the long run. Very large positive x's or very large negative x's. Where is the function going then? Well, here's the key for that. Look at the ratio of the leading terms. If this ratio is a number, like this one is, 2x over x, the x's divide out, and you have 2 over 1, which is 2. That's your horizontal asymptote. Y equal 2. Remember, f of x is y, so y is equal to 2. In the long run, this is where they're heading. And you see this branch is going toward x equal 2, and this branch is going toward x equal 2. Getting closer and closer and closer. They could touch or cross, but that's fine. These won't. They'll just keep getting closer and closer. Vertical asymptotes, they cannot. Okay. So here's another function. This is the one we're going to look at here. And in this case, your denominator is never equal to 0. X squared plus 1 cannot be 0. Because if you square x, it's always going to be a non-negative number. Add 1 to it, it's always positive. Right? So therefore, this will have no vertical asymptotes, and it does not. However, the ratio of the leading terms is 4 over x squared. And as x gets very, 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 very large, 4 over x squared gets infinitesimally small. 4 over 2 million is a very small number. So in the long run, this is going to y is equal to 0. F of x going to, for very large x's in behavior, going to 0. Okay? The third example here, f of x is equal to 2 over x minus 1 squared. Okay, what would be your vertical asymptote? What do you worry about here? Anybody? Vertical asymptotes. All right. Your Deja, right? Okay. All right. Anyone else come in while I wasn't looking? Okay. Or while I was looking? Let's see. Okay. What do we worry about here? What's one thing that might be bothersome? Anybody?
Square.
Say again?
Square. Square. Square.
Squared. Okay. That's not a bad thing to be squared. Well, to be square maybe, but to be squared, no. Okay. What is the thing that's of greater concern? Say again? Okay. How does that bother you? Okay. Where is this expression located? In the bottom, the denominator it's often called. And what can denominators ever be? No, they can be negative. 0! You can never divide by 0. I thought that'd be patently obvious by now. And what would make that denominator 0? X equal 1. If x is equal to 1, that means a minus here. Okay, no, okay. Okay, I know you're in here. There you are. Okay. All right. So, you cannot have x equal 1, so I like to say x cannot equal 1, because that would make your denominator 0. So x equal 1 is a, what do we call that? That line? Which one? Vertical asymptote, absolutely. The function cannot touch it, it can't cross it at all. Okay? X equal 1. Okay? Here's the on. Okay. Okay. So that's your vertical asymptote. Where do we look for the other one? What is it called? Horizontal asymptote. What determines the horizontal asymptote?
equals 0.
Say again?
Y equals 0.
Okay, it is y equals 0. Okay, you read that well. Okay, now, why is that true? What you do is look at the ratio of your leading terms. If you square this out, the leading term here will be an x squared. This will be 2 over x squared. And for very large x's, either very large negative or positive, then that's going to 0. Okay? And sure enough, the function's going down here and here. Now, something you might note, okay, and this is, since this denominator is squared, and someone pointed that out right at the very beginning, it's squared, that means it can never be negative. It could be 0, it is 0, but it can't be negative because it's squared. And 2 is positive. It's not negative. So therefore, this function is always positive. And sure enough, it is. Because the numerator is always positive, the denominator being a square is always non-negative, so therefore it's never crosses to the downside. Same thing here. This is positive. This can never be negative, so therefore this one stays above the x-axis. This one, however, could be positive or negative, and you see, sure enough, negative down here. Okay. Any questions on those? Vertical and horizontal asymptotes. Okay. Now, we have a name for this. This is that first one we looked at way back. F of x equals 1 over x. Pretty simple polynomial functions here. 1 and x. Okay, those are polynomial functions. Okay. This is the graph of it right here. Vertical asymptotes. X can't be 0. There it is, the y-axis. Horizontal asymptote. 1 over x is very, very large. That is approaching 0. Okay. So there's your deal. You call these shapes here when you have a curve and this other curve and they're going in opposite directions, never combine. These are at an angle like that. You call these hyperbolas. Okay? You may run into that in future math courses. Some of you may not be taking any future math courses, but that is one of the shapes. They're called conic shapes. They come from looking at cutting cones in different ways, so they're called that. But those are called hyperbole. Okay. So here is the description of vertical and horizontal asymptotes of a rational function. Let f be this rational function. Of course, a rational function is a ratio of 2 polynomial functions. Your numerator function and your denominator function. Numerator function is a sub n, x to the nth, plus a sub n minus 1, x to the n minus 1, blah, 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 on down until you get a sub 1, x to the first, plus a sub 0, times x to the 0, which is 1. Okay. A typical polynomial function. The n's for the exponents, those are really important. Those have meaning in the problem. The n's that are the subscripts of the coefficients, that's just designated which exponent this coefficient goes to. So these are almost meaningless. They're just identifying this is the coefficient for that power of x. Okay? Your denominator is some other function, b sub m, x to the nth, plus b sub m minus 1 times x to the nth minus 1, all the way down to b sub 1 times x to the first plus b sub 0 times 1. Okay. Now, that is your most generic form, but hard to read and understand, of any rational function. N of x is, okay, here's a key. Catch this one, folks. N of x and d of x have no common factors. Okay? No common factors. If you have a common factor, factor it out. Okay? And then you're left with something else. Okay. I always have trouble finding your name. Second? Yeah, Sadler, but I don't remember your last name, so thank you. It's Kiara. I knew that was right, but that went far enough down. Okay. Good deal. Anyone else come in since I called roll? All right. So, N of x and D of x have no common factors. If they have common factors, divide them out. Okay? And you'll still have a polynomial in the numerator, polynomial in the denominator. So guess what that suggests to you? The very first thing we do when we have a rational expression, see if we can factor those expressions. Factor that numerator, factor the denominator, see if you can find any common factors. First step, they should have said that right at the beginning. As soon as they said this, therefore factor both of them first. Okay? Now, factor just for that? No. Okay? If you factored that denominator, then you already can find, usually pretty simply, what your vertical asymptotes are, because any factor that becomes 0 would make the whole denominator 0. So therefore, the factoring is very helpful in that respect too. It identifies where your zeros are. Where your zeros are in the denominator, that's going to be your vertical asymptote. As many as you have. Okay? Then the graph of f has 1 or no. All right. TK, right? All right. All right. The graph could have 1 horizontal asymptote or no horizontal asymptotes. Okay? That is determined by comparing the degrees of the numerator with the denominator. Now they look at the whole degree, and it's fine. The degree is the maximum exponent of the numerator, maximum exponent of the denominator. To me, I make it a lot easier than that by looking at just the ratio of the leading terms. Okay? Who cares about the rest of it? For the long run, these are the ones that count, that leading exponent. Because these down here, if this is, give me a value for n. Make up a value. Second?
1.
Okay. How about a little bit bigger?
3.
Second?
3.
3. Okay. If the numerator was degree 3, Tadarius is here. Okay. And Q is here. All right. Good deal. Now, so your numerator has degree 3. All right. The next one, this would be a 2 here then, right? So let's take a big number. Not too big. Like 10. 10 cubed is how much? 1,000. 10 squared is 100. 1,000 overweighs 100 big time. And if you get even bigger, it overweighs it even bigger. Okay? Now, give me a value for m, the maximum exponent of the denominator. A number, any number.
2.
Second?
2.
2. Okay? So you had a 3 up here and a 2 down here. What's the ratio of those two? X. Because x cubed divided by x squared would just be x. Well, guess what? For very large, either negative or small x's, negative or positive x's, okay, very large ones, the ratio is going to be a huge number. Either positive or negative, but it's going to be a huge number. So therefore, this will not have a horizontal asymptote. If the degree of the numerator is greater than the degree of the denominator, no horizontal asymptotes. And that's what they say here. When n is greater than m, the graph has no horizontal asymptote. But you see that if you do the ratio. The ratio would be whatever a sub n over b sub m is. Who cares what that is? If you have left the x up here with no x down here, and x is very large, positive or negative, there's no horizontal asymptote at all. All right, so let's go to the case where n may be less than m. Okay? So let's leave our n at 3, but make our m something greater than 3. Give me a number greater than 3. 4. Okay, very good. Wise choice. And you do the ratio of that, you'll have a over b, whatever that is, a sub n over b sub m. But then you'll have x cubed up here, x fourth down here, that'll be 1 over x. And as x gets very large, positive or negative, that thing goes to 0. 0. Absolutely nothing, because 1 over a very large number is getting closer and closer to 0. So therefore, the graph will have y is equal to 0, which is the x-axis, as the horizontal asymptote. And we saw that in one or two of the examples before. Okay? So, what if n is equal to m? 3 and 3, 4 and 4, 2 and 2, whatever they are, you look at that ratio, those completely go out, and then you have the ratio of a sub n over b sub m. That's going to be your horizontal asymptote. Y is equal to the ratio of the leading coefficients. Okay? So in every case, do the ratio of leading terms. If you wind up with x in the numerator, no vertical asymptote. X in the denominator, y is equal to 0 is your, horizontal asymptote. Okay? And if those two are equal, then the ratio a sub n over b sub m, that's your horizontal asymptote, whatever number that is. It's pretty straightforward. Any questions about that? Okay? Let's do a couple. Okay? Let me first get my pen set up. Okay. Now, it says find all vertical and horizontal asymptotes of the graph of each rational function. So sort of in there, they snuck it in. We're going to wind up graphing them anyway. So let's start with the vertical asymptotes. How do you determine the vertical asymptotes?
X equals 0.
Say again?
X equals 0.
X equals 0. Okay? Where x is equal to 0, that's going to be your y-intercept, right? When x equals 0, that's y-intercept. And in this case, that's 0. Okay? So, you answered a good question. It just wasn't the question I asked. You have your y-intercept, which turns out being the x-intercept as well, is 0, 0. Okay? This graph goes through the origin. That's your y and your only x-intercept. Okay? We haven't talked about that yet, but you hit that one right. By mistake. Okay. How about vertical asymptote? What determines the vertical asymptote? Second. The denominator. What about the denominator? Wherever it's equal to 0. Now, the first thing we should have done, and I should have suggested it, is we need to factor. Well, the numerator is a monomial. You can do 2 times x times x. That's fine. You could factor that, but we really need to factor that denominator. And can we factor the denominator? How? Second? Minus 1 times x plus 1. Okay. All right. Those are conjugates of each other, remember? Okay. X times x is x squared. X times 1 is x minus x, 0x minus 1. Yeah, that works. Okay? Now ask again, what makes that denominator 0? See, when you get it in factored form, it's really easy to see, hopefully. Okay, yeah, set each of them equals to 0, and what does this become?
Positive 1.
X equal 1, and this becomes?
Negative 1.
X equal negative 1. Only I would say x can't equal positive 1, and x can't equal negative 1. Those are your vertical asymptotes. The book will say x equal 1 and x equal minus 1. Those are the vertical asymptotes. I like to say it can't equal that, meaning don't go there. Don't ever touch it. Okay. Vertical asymptotes. How about horizontal asymptotes? And those are the only two places that denominator will ever be 0. Okay? That gives you your vertical asymptotes. What gives you your horizontal asymptote? It's been a long time, I realize. At least 5-10 minutes. What gives you?
N is less than M.
The what?
N is less than M.
Well, you tell me. What's your N here? Not that I remember N and M's that well, but 2 and 2, whichever is which. That's not less than, they're equal.
Right. So if they're equal, then okay, it's supposed to be A to the N
Over
B.
Okay. Now, you're using the definitions book, which is perfectly correct and everything. My shortcut says, look at the ratio of the leading terms. And what's the ratio of that leading term? Second? 2. And y is equal to 2. There's your horizontal asymptote. These are the vertical asymptotes. This is the horizontal asymptote, is y is equal to 2. The ratio of the leading terms. Okay. So, we did what they said. Find all the vertical asymptotes and the horizontal asymptote of the graph. They sort of want us to do the graph. So here's how we proceed with the graph. You've already found the point for us, okay? By mistake, but you did. And that's both the x and the y intercept, 0, 0. So let's do the graph, okay? So we'll do 1, 2, 3, 4, 5. Then I go 1, 2, 3, 4, 5. Positive 1, 2, 3. And here's Tara. All right. And by the way, I should have said this earlier. Just put one of the announcements I forgot because I have one mnemonic device back there on my the desk in my other room. I forgot to bring it in here. Here's Hamina, if I can find you. I know you're in here. There you are. Okay. All right. But the reason we had a shortened class last time was because it was Honors and Awards Day. And several of you were honored, and I was really happy to see. So congratulations, all of you that were honored at Honors and Awards Day. Some of you weren't there, of course, because you were out playing games or something, but you did get some honors there, too. There you go. Okay, so for all of you, several in this class were recognized, and that made me feel really good. Okay, not that I had anything to do with it, but still, I said, I know that person. Yeah, I know this famous person. Okay. All right. So, let's identify. We know that 0, 0, we landed on that suddenly. That is a point on the graph. Whew, wow. Whole graph, we got 1 point. But we also know that the vertical asymptote, and since that's an asymptote, I'm going to put it in red, is x can't be positive 1. This vertical line through positive 1, and x can't be negative 1. My y-axis is not very straight, but something like that. Okay? And our horizontal asymptote is y is equal to 2. And that's something about like that. I'll put it red too, even though you could cross or touch it if you know, the function, no problem with doing that. All right. Now, this may be a little beyond what you're used to now, but believe it or not, you can tell what's going on now. Okay? Here we know we have a point here. And the function is either got to go up or down from there, because that's the only x-intercept. Of course, it's the only y-intercept. Now, the function, the odds are, I'll take that back. I was going to say it can't go up because of the horizontal asymptote. It could go up because it can touch the horizontal asymptote. Okay, so we'll hang off of that for a moment, though I do know which way it's got to head. Okay, so what we don't know is what happens out here. We don't know here either. So let's just take a couple of points, like x equal 1/2. Okay? And let's get it in the factored form here. When x is equal to 1/2, this is a positive number. X squared would be 1/4. 2 times 1/4 would be 1/2. X equal 1/2 here, that would be 1/4. Minus 1, that would be a negative number. So at 1/2, you're going downhill. You're below the x-axis. Let's take a negative 1/2. Well, this is still positive, right? Negative number positive squared is still positive. Well, this is still positive 1/4 minus 1. That's still negative. So we do know it's going downhill to the left. Oh, let me get my pen back. Okay. And it's going downhill to the right. Okay. Now, the other way I knew that was this is what kind of function? Notice the exponents.
Quadratic.
It's what? I can't hear.
Quadratic.
Okay, it's quadratic for sure. Okay, but that is what kind of number?
Square. 2.
2.
Even.
And that's a?
Parabola.
Okay, yeah. Okay, it's parabolic in shape. You're right there. This is a?
Even.
2, and this exponent would be a? 0. What can you tell me about 2, 2, and 0? What kind of numbers are those?
Even.
Even numbers. And if these are all even, there's a good chance this is a?
Oh.
Take it.
Vertical. No.
Plus origin.
What about, no, not about the origin. The y-axis is symmetric about the y-axis. Even functions are symmetric about the y-axis. They do the same thing on one side as the other side. So if this is going down, that's going down. Okay? So, even function. Okay. Now, let's pick a point over here and over there because we have no clue. We know we can't touch that vertical asymptote or that vertical asymptote, but we don't know which way we're heading here. Okay? So let's take what you want to do first, positive 2 or negative 2. It really doesn't matter. Negative 2? Okay, negative 2. Plug that in here and what do you get? 4 times 2 is?
8.
8. So 8's in the numerator. This would be a 4 minus 1 is 3, so 8/3. Okay? Well, 8/3 here would be 2 1/3, right? So that would be somewhere about right here. Okay? That right there is enough to tell you where the function is going here. It's going to approach the horizontal asymptote this way and the vertical asymptote that way. Okay? If you do positive 2, guess what? It's going to do the same thing, isn't it? So, because it's an even function. So it's going to go like that. Which is pretty interesting. The function never has a value between 0 and 2. Interesting, but true. Okay. And if you look in your book, you see something very close. If I look in my roll book, I see that Asia is here. Just got to get you on the right line. All right. Did anyone else come in since I called roll? Okay. Now, so we see how the graph. Okay. Luckily, we found our intercepts. The y-intercept is where x is equal to 0. That gave us 0, 0. Okay, because the numerator was 0. This would be 0. X equals 0, y is equal to 0. Okay? That turned out to be our only intercept. Okay? Vertical asymptote is where that denominator is equal to 0, and that would be that x can't be plus 1 or minus 1. Draw your vertical lines in. Horizontal asymptote, ratio of the leading terms, that gave you y equal 2. Draw in your horizontal asymptote. Okay? Since you had one point here, just had to do a test point on either side to see which way it's heading, and that tells you it's got to keep going that way. Do one point here, and that tells you where it's heading there as well. Okay? There you have an even function, reflective across, or that's not the word, symmetric across the y-axis. Okay, so that was the A part. Okay? All right, to erase, because I need to do the B part, and that's taking up all the room. Okay. So, what would you suggest we do with the B part? Factor, numerator and denominator if they're factorable. So that numerator, if it's factorable, what's going to be the first factor? X times x, perfect. Then we look at the sign of the last term, which is, and what does that tell you about these two signs? They're different, so one's going to be a plus and one's going to be a minus. It doesn't matter which order you put them. And what would be the values that go there? So again, 2 and 1. Okay? Check it and see. X times x is x squared. That works. This would be minus x plus 2x. It will give you a plus x minus 2. Perfect. Okay? How about the denominator? Will it factor? We don't know. If it will, what's going to be the first factor? X times x. Sign of the last term is negative, so it's plus and minus again. And then we have two numbers that multiply to be 6, but because this is a different sides, their difference is 1.
Minus 3 plus 2.
Is what?
Minus 3 plus 2.
Minus 3 plus 2. And what do you notice we have here, folks? We have a common factor divided out. But before you divide it out, or while you can still see it, notice that x, and by the way, here we had written here, x can't be plus 1 or minus 1. X cannot equal 2, minus 2, or positive 3, right? Because x can't be minus 2, that would have made your denominator 0. X can't be plus 3, that would have made your denominator 0. But this one is not a vertical asymptote. This one is. So your only vertical asymptote is x cannot equal 3. The x can't equal negative 2, that's still true, but it's not a vertical asymptote. We'll see how that plays out in a minute. Okay? So, we got our vertical asymptote. What else are we supposed to find? Horizontal asymptote. And how can you find that? Second?
First term.
Do what?
First term.
First terms, ratio of the leading terms. And what is that?
0.
Second? 0. Oh, wow. Our leading terms are zeros. That means we don't have a polynomial, does it? Which doesn't mean we don't have a rational fraction. No, I don't think it's 0. What's the ratio of x squared to x squared? 1. So this would be, horizontal asymptote would be y equal 1. Okay. Now, there are a couple of other things we need to investigate. Number 1 is anything that would make the numerator 0. And the reason I say that is if the numerator is 0, that means f is 0, right? If that numerator is 0, f has got to be 0. So that's going to be, so any value for x that makes this equal to 0 is going to be an x-intercept. But we know x can't equal negative 2. We've already said that. So x equal negative 2 is not an intercept because it can't equal that. We've already determined that. But x equal 1 would make that. So we do have an x-intercept at 1, 0. Because the y is 0 when x is equal to 1. Right? There's your x-intercept. How about y-intercept? Can we determine that? What makes a y-intercept? Somebody's already done one today without meaning to. What makes a y-intercept? Second? X equals 0. Well, if you put x equals 0, guess what? What do you have left?
Minus 2.
Second? Negative 2 over negative 6, which is?
1 over, minus 1 over 3.
Not minus.
1 over 3.
1/3. Okay? So your y-intercept is 1/3. Okay? So you have x equals 0, y is equal 1/3. Okay. I've got to find you. Alana? Okay, I thought so. Okay, good deal. All right, anyone else come in since I called roll? Okay, so we found our y-intercept as well. About the easiest thing to do, say x equals 0, whatever's left, that's going to be your y-intercept. Okay, so about all we can do with that, except graph it. Okay, so let's draw our graph here. Okay, we'll take off some points here. 1, 2, 3, 4, 5, 6. Negative 1, 2, 3, 4, 5. Positive 1, 2, 3, 4, 5. Okay, something like that. Not very even spacings there. All right, let's pick off the things we know. X-intercept at 1, 0. Y-intercept at 0, 1/3. Vertical asymptote at x not equal to 3. 1, 2, 3. Boy, that's your. Whoa! Let me do these in red. Now, I want to make a little mark here. X can't be negative 2, so I'm going to just put a little circle there to remind myself x can't be negative 2. It's not a y-intercept, but x, okay. Horizontal asymptote, y is equal to 1. There we have that. Okay. Now, unfortunately, all of our information is in one quadrant, but that tells us exactly where this function's going in that quadrant. Okay? And it must be approaching the x-intercept there and the y-intercept there. No choice but that. Okay? Now, with one exception, x can't equal negative 2. So this one that you factored out, that leaves a hole in the graph because x can't equal negative 2. So it doesn't go through negative 2, it just skips over it. There's a hole there, okay? Can't do it, okay? So we need to do a test point here, and I would suggest at x equal 4. So let's apply x equal 4 and see what we get. What's 4 squared?
16.
16 plus 4 would be? 20. Minus 2 would be? 18. So remember, the numerator is 18. Denominator?
16.
16. Minus 4 would be? 12. Minus 6 would be? 6. Okay? So that was 18 over 6. Is that right?
Yeah.
That was positive 3. So when x equals 4, y is equal to 3. Right there, I think, or somewhere there. But that's all you need, because you know it's got to approach the y-intercept there and the x-intercept in that direction. So there we have it, a hyperbola, okay, curved in opposite directions, and there, sure enough, is what it looks like. And if you look in the book, you'll see it there too. In fact, we may even, they don't do that one, do they? They just showed the first one. Shame on them. Okay? So, any questions on this? So again, just sort of get your procedure down. If you can factor, numerator, denominator, factor everything inside. Okay? If you have any common factors, dismiss them, but remember x can't be 2 because 2 will still make that denominator equal to 0. This other one that doesn't factor out, that's a vertical asymptote. So the x equal minus 2 is going to give you a hole in the graph. Wherever that graph is, it's going to give you a hole. Okay? The x can't be positive 3, do your vertical asymptote there. Ratio of leading terms, that's going to give you your horizontal asymptote if you have one. You may not have one. Set y is equal to 0. Of course, y is equal to 0 is going to happen everywhere that the numerator is 0. Okay? So x equal 1, you know that you've got a y-intercept there, and x equal negative 2, you would have had 1 there, except it can't be negative 2. That's your hole in the graph, so don't put 1 there. Okay? And then the y-intercept is really easy. That's where x equals 0. So wipe out the x's, and you get positive 1/3. Okay. Now, that gives you all the points you can get. Draw in your vertical asymptote, your horizontal asymptote, apply all the points you know. Okay? We don't know this one yet, but We know this one and that one. That tells you got to be in this quadrant down here. When I say quadrant, it's the quadrant of your asymptotes. You only have one vertical, one horizontal, so that splits it into 4 pieces. So pick a point over here to see whether you're down here or up there. You happen to be up there, so you know where it's going to. Okay? And that gives you a hyperbola. Now, but when you draw this one in, remember you have to leave a open circle at x equal 2. Because or negative 2. X cannot equal negative 2, so you have a hole in the graph there. And this one they should have shown, but they didn't. Okay. That's the procedure. Factor, determine your zeros in numerator and denominator. Zeros in numerator give you your x-intercepts. Zeros in the denominator give you your vertical asymptotes. Or, unless you cancel out a term. Ratio of leading terms, horizontal asymptote, and where x equals 0 is your y-intercept. And then after that, pick points if you need them. So let's clear the slide, and let's see them do number 1, the 8. The degree of the numerator, okay, equal, okay. You can do that if you want to. If you just do ratio of leading terms, you get the horizontal asymptote, which is 2. You don't have to worry about degrees and stuff. If you do the ratio of leading terms, you'll see those cancel out, meaning they were equal, and you get 2. Y is equal to is horizontal asymptote. You can do it the way the book says. That's perfectly fine, but it's just a little unnecessary. Okay, vertical asymptotes is where the denominator, remember, denominators cannot be 0, so I would put this cannot equal 0. They like to put it equals 0. Factor that. In fact, factor everything in sight even before you start, and you could have done it right there. X can't equal negative 1, and x cannot equal positive 1. Okay, we got those. Okay, and 2 real solutions. Those are that equation, the denominator. So therefore, vertical asymptote at negative 1 and positive 1. Y, x equal. Okay, then they just throw the rest of it up there, which you can't really do. All we had was this point, this vertical asymptotes, and 1 horizontal asymptote. You have to pick a point here and here to convince yourself it's going downhill in both places. Pick a point here to see where you are here. Pick a point here and you go there. If this would have been here, you could have done like this, okay? Or this could have gone like that. But pick a point and see where you are within those. And you got it now. Okay. They didn't say anything about intercepts. They should have. Here's the B part. Very similar, except I don't think they'll graph it. Maybe they will. Okay. The leading coefficient, both the numerator and denominator, is 1. So the ratio of leading terms is y is equal to 1. So they sort of jumped right to that there. Well, no, they did rational. The degree of the numerator is equal to the degree of the denominator. If you just do ratio of leading terms, that tells it to you. Okay, vertical asymptotes, you factor the denominator, and you see that's there, but you factor everything. You should have done that very first step. Factor everything, and you see you lose your x plus 2 as factors. However, x can still not equal negative 2. It won't be a vertical asymptote, but it can't be there. That's going to be your hole in the graph. This x cannot equal 3. That's going to be your vertical asymptote. Your numerator, this will give you an x-intercept at x equal 1. Okay, 1, 0. Because that would make this 0. If x equal 1, that makes this a 0, so that makes your y a 0. So 1, 0 is your x-intercept. Negative 2, 0 would have been, except they went out. And x can't equal negative 2, so don't even do that. Okay? And then what they didn't do is your y-intercept to set x equals 0. You get 1/3. Okay, so x cannot equal negative 2, but it's not a vertical asymptote. X also cannot equal a positive 3, and that will be a vertical asymptote. So why don't they put cannot equal 3? Should have that there too. Now, they don't sketch the graph of that one, but here they tell you how to sketch the graph. All right, nothing too new here. We just did it. The f of x be your rational function n of x is a polynomial function in the numerator, d of x a polynomial function in the denominator. Okay? And d of x can't be the zero function polynomial. If it is, you can't do anything because that would just be zero. Now it says simplify f as possible, which means factor everything in sight. Factor the numerator, factor the denominator, see if any common factors exist. If they do, factor them out. But remember, even though you factor it out, it still can't be the zero down there. They just won't be y-intercepts. Okay? Then it says, once you factor that denominator and you eliminate the common factors, any other factors of that denominator, those will, oh, wait. Sorry. Okay. They finally said what I was saying. Easiest thing to do, set x equals 0, and you get your y-intercept. That is the easiest thing to do with those, because every term will be 0 except those two common terms, or the constant terms. That ratio will be your y-intercept. Find the zeros of the numerator. Those would be your x-intercepts. Okay? Any that you didn't factor out, those would be your x-intercepts. Plot the corresponding x-intercept. Plot your y-intercept. Find the zeros of the denominator. Any that you factored out are going to give you a hole in the graph. If you didn't factor them out, those are going to be vertical asymptotes. Okay? Sketch the horizontal asymptote by taking ratio of leading terms. They say the rule, blah, blah, blah. Just do the ratio of leading terms. It'll tell you what it is. May not have one, or maybe 0, or it may be some other number. Okay. Now, once you've done all that, you sketched your y-intercept, you sketched your x-intercepts, if you have any. Okay? You've found the vertical asymptotes, holes in the graph for vertical asymptotes, and you've got your horizontal asymptotes. Plot all that. If you have some points already known, enough to say, then you can plot the graph right then. If you don't, then find at least one point between some of your other points. Outside your asymptotes, between your asymptotes, wherever, and plot those points. After a while, you'll see where everything goes. Use smooth curves to complete the graph. No points, no cusps, just smooth curves. The concept of test intervals can be extended by graphing rational functions. To do this, use the fact that a rational function can change signs only at the zeros or at its undefined values, vertical asymptotes. Okay? Between two consecutive zeros, the numerator and the denominator, a rational function must be entirely positive or entirely negative. Yeah. That means that when put in order, you put the zeros of your numerator and the zeros of the denominator in order. Zero denominator is going to be vertical asymptotes unless they divide it out. Zeros of the numerator are going to be your x-intercepts. Then that divides the real number line into test intervals in which the function has no sign changes. So if you find a point there, you know it's not going to cross again. Choose a representative x value to determine whether the value of the rational function is positive or negative. Okay? Plot those points, and you'll have enough to fill in your graph. So here's a pretty easy one. Sketch the graph of g of x is equal to x over 3 over x minus 2. I can't even read. State the domain. Okay? Frankly, I would state the domain first. Okay? I don't know why they say it the other way. What would be the domain of that? We always assume the domain's going to be all real numbers unless there's some problem. Is there a problem? Look at your denominators. That's where most of your problems come, isn't it? Okay. What can the denominators never be? 0. Okay, number 1. This is already factored. You can't factor it any further. So now we say the denominator, x minus 2, cannot equal 0. We know that's true, right? You can never divide by 0. Solve that inequality, what do you get? x cannot equal 2. That's a pretty ugly 2, but it's a 2. Okay. X cannot equal 2. What is that? Vertical asymptote. Okay. So here, let's go on and get started on it. 1, 2, 3, 4, 5, 6. Negative 1, 2, 3, 4, 5, 6. These are not very evenly spaced. Okay. So, x cannot equal 2. Whoops. Make that red. X cannot equal 2. We've already got something. All right. Now let's consider our other things. A really easy thing to do, the easiest thing to do is your, anyone remember? So x equals 0, that gives you your y-intercept. X equals 0, what do you get? Negative 3/2. So there's your y-intercept is, let me get back to black. Okay. 0, negative 3/2. Okay. That would be negative 1.5 right there. Okay. Now, that's your y-intercept. Really easy. Just say x equals 0, and that gives you y is equal to negative 3/2. Okay. Y-intercept. X-intercepts. That's where y is equal to 0. What's your y in this case? G of x. That's your y. Okay? But that's only 0 when the numerator is 0, right?
Right.
Is 3 ever 0? Is 3 ever 0?
0.
Is 3 ever 0?
No.
No, it's never 0. It can't be 0. So therefore you have no x-intercept, x-intercepts. No x-intercepts at all. Never going to touch the x-axis. Which almost gives it away that that's your horizontal asymptote. Because 3 over x gets very, very large. It's going to 0. Either positive or negative, very large x's, that's going to 0. So the y is equal to 0 is your, okay, here's your vertical asymptote, okay? Your horizontal asymptote is y is equal to 0. So I'm going to go back to red just for a moment here and just do my x-axis as my horizontal asymptote. Okay, the book never does that because the typesetter can't do that. Okay, I can. Okay. All right. Okay, there's no x-intercepts. You have your y-intercept. You have your vertical asymptote, your horizontal asymptote, so you know the function has to be going like this and like that. There's no choice. That's its only possibility. The only test point you need is a point out here somewhere. So why not let's choose 3. So let's use g of 3. And what would that be? You tell me. 3 over 3 minus 2, which is 3 over 1, which is 3. So when x equals 3, y is equal to 3. 1, 2, 3, somewhere up there. That would be right there. Then that tells you it's got to be going like that. No other way. Okay? There's your graph. Right there. Any questions? Pretty easy to do. Now, I didn't bring my watch. Yes, I did. I did stick it in my pocket. Oh, we got plenty of time. Excellent. Okay. So, there was example 3. I hadn't turned the page for it. All right, so I think we got that done. Y-intercept, x-intercept, none. Vertical asymptote, horizontal asymptote. Draw in what you can, and choose a test point for anything you don't know. See it? Make sense? Let's see how they do it. Okay. Can I erase? All right. So it says sketch the graph. What do we do? All right. Y-intercepts are easy. Okay. What they didn't say, factor everything in sight. Nothing factorable. Done. Okay. Next, y-intercept. Say x equals 0, y is equal to negative 3/2. You see it? Mm-hmm. So there we have our y-intercept right off the top. Now, don't know if they do x-intercepts next. Let's see. Yes, x-intercept. That's where the y is equal to 0. The only way y can be 0 if that numerator is 0. And it can't be 0. So there's no x-intercept because 3 cannot equal 0. Okay? So that's done. And that almost gives it away that probably your y is equal to 0 is going to be your horizontal asymptote because it never will touch there. We don't know that yet, but we're going to know it in a second. Vertical asymptotes, the denominator can't be 0. X equal 2 makes the denominator 0, so that's your vertical asymptote. I say x can't equal 2. Just to remind you, you can't go there. Horizontal asymptote, ratio of leading terms, and as x is very, very large, 3 over x is going to 0 in both directions. Okay? So y is equal to 0. And it is because the degree is that, but if you just do let x get very, very large, you'll see that's going to 0. Okay? Make sense? That's all we can do with what we've got. So let's graph what we've got so far. They say additional test points. They do a little extra. It's fine. It doesn't hurt anything. But you really didn't need that first one. If you just plotted what you had, vertical asymptote here, horizontal asymptote there, y-intercept there, you know this one has to be here. You don't need that point, but it doesn't hurt to put it. Okay, there's your graph there. You do need one over here, and I think they did that, didn't they? Yeah, x equal 3, yeah, same as us, and they found that was equal to 3 also, so therefore you're up there, so it has to be in that quadrant. Make sense? I'll try to get out of the way. So it's really not too bad graphing these. Does it guarantee your shape is exactly right? Probably not, but just come close, okay? Get it in the right ballpark. Can I go on, or do y'all need it a little bit longer? I'll get out of the way. See, to me, this test point was not necessary. You already knew what it was going to happen down there. Okay. This one was necessary because you didn't know if it was up there or down there. So you do need that test point. When you got it to be +3, you know exactly where it's going. Make sense? Any questions? All right. Oh, their second part of the question was find the domain. As soon as you saw, let's go back. As soon as you said x cannot equal 2, that's your domain. All real numbers except x equal 2. So x equal minus infinity up to 2, and from 2 to positive infinity. Okay? So that's what they finally say here. When it's patently obvious that's true. The domain of G is all real numbers except x equal 2. Okay. Now, they are skipping examples 4, 5, 6. So let's go back and do all right. Let's try to do example 4. We may not get it all done, but at least let's get started on it. By the way, every one of these examples has a checkpoint, so check them out. Sketch the graph of f of x is equal to 2x minus 1 over x, and state the domain. Can anyone state the domain for me already? What about x? Yeah, x determines the domain.
equals 0.
X cannot equal 0. All real numbers except x equals 0, which then is a pretty good indicator x equals 0 has got to be a vertical asymptote, right? Because x cannot equal 0. So you already got your domain and you've got your vertical asymptote without really trying anything else. Vertical asymptote is x cannot equal 0, because that would make your denominator 0. So that one's done already. But what was usually the first thing? Well, first thing we try to factor, it's prime. There's nothing you can factor. So then the next easy thing was, usually the easiest thing is your y-intercept. And what is your y-intercept? X equals 0. So what is it when x equals 0? Oh, it can't be 0. So there is no y-intercept, because x cannot equal 0, okay? That one's done for you, okay? You got your domain, you got your y-intercept, and you got that there's no, your vertical asymptote, and you got there's no y-intercept. Okay, next. Horizontal asymptote, what would that be? Horizontal, 2, okay? Y is equal to 2, ratio of leading term. Horizontal asymptote is what? Y is equal to 2. Okay? One thing we're still missing, x-intercept, and what's true about that? That's where your numerator is equal to 0, because the only way that y can be 0 is that numerator be 0. Or what would make that true? 2x minus 1 equals 0. How would you do that? Add 1 to both sides, and that gives you 2x is equal to 1, because that adds a 0. Divide by 2, so x equal 1/2. So there's your x-intercept 1/2, 0, because you set y is equal to 0. Okay? All right. So you got all the information you can glean out of this. So let's do our thing here. 1, 2, 3, 4, 5, 6. Negative 1, 2, 3, 4, 5, 6. Positive 1, 2, 3, 4, 5. Negative 1, 2, 3, 4. Okay, whatever. Okay. Plot what we've got. Vertical asymptote is your y-axis, right? X cannot equal 0. Horizontal asymptote, y is equal to 2. Got those done. There is no y-intercept because it's the vertical asymptote. Can't ever touch it or cross it. Your x-intercept, though, is 1/2, 0. Okay? 1/2, 0 would be right there. X-intercept, 1/2, 0. Okay? That tells you you've got to be right in here and right in here. Okay? Done. Now what? Now what? Second? You're not through. What do we do next? We got this part. Happy. Hunky-dory. What we don't have is that part. And that's, I'd say, a -1. That's the easiest thing to do. Let's do f of -1. What would that be? 2 times -1 over -1. Okay? 2 times -1 is? -2 minus 1 over -1. That would be -3 over -1, which would be 3. So there you are. -1, 1, 2, 3. Right there. So that tells you got to be going up there and out there. There you have it. Can't get much simpler than that, can you? Okay. That was example 4. I don't think we're going to have time for example 5, are we? So this is where we'll start next time, is example 5. So let me erase that. All right. Let me give you some homework exercises, because I know you would hate it if you left class without any homework to do. And you can do either 5 or 7. They're both at Calc Chat. 7's at Calc View. Any of the odds 9 through 15, they're all at Calc Chat. 15's at Calc View. Any of the odds 17 to 37, they're all at Calc Chat. 27's at Calc View. think you can do all of 39 to 42. However, only 39 and 41 will be at Calc Chat and in the back. And I think you can do 43 or 45. You can try those if you'd like. And we'll pick up the rest of them next time. All right. I'm anticipating next time finishing 2.6, which means Tuesday we'll have the test on Chapter 2. All right? Got it? Y'all going to schedule a game real hurry, aren't you?
Tuesday
No, never. I'm just kidding.
Thursday we won't be here, but Tuesday we will.
All right, you'll be here for the test. Way to go. I knew you would do it for me. All right, good deal. Thank you. Yours what? Ripped? You got that frustrated with it, huh? All right. Here somewhere. You need graph paper too?
Yes, if you have some, you don't need a paper.
That is my last one.
Okay.
Okay, I'll have to make more copies. You say you need graph paper?
Thank you.
I got more of that.
You graded test 2.
Huh?
You graded test 2.
Test 2 we haven't had yet.
I mean, quiz 2.
Quiz 2? Yes, I have. I think you did okay.
I know.
Maybe a D minus. No, you did good. Okay.
Man 6.
Yeah.
What are these?
Okay. Lots.
Yep. Yep. That's right. That's all right.
There you are. Okay. This one?
Yep, that's all right.
Boy, he was some kicker. He must have been a cricket player. No, they don't kick. That's never mind.
They hit.
Huh?
They hit.
Yeah, they hit. And way too tall. I don't know if you saw the minus sign, but you must have because you got a positive number there. So, anyway. And then this one, I couldn't see your work, so I don't know how you missed that. But when you did your division there. Oh, there you go. I'm sorry, I didn't finish it. Okay. Let's see. X minus 1 into x cubed. Okay.
That's right.
Let's see. That'd be x squared. That'd be x cubed. Minus x squared. Where did you get it? 2? Oh.
And there is
You
1.
made one up. Okay. All right.
So I need to practice this.
Yeah. I didn't see that one. Well, that's where you mess that up. Oh no, you did it all right. Okay.
I got this.
Okay.
It was
That
like,
would have been your answer.
yeah. Then I did the.
Yeah, but no. Here's a minus, and that's a minus. And minus over minus. Okay. See, you wrote it here. You don't have an x in there. Okay, that's one thing. This should be a minus b. And you left off the minus for the b, because it's not a negative number. It's a positive number. Okay. Minus over
So
minus.
I don't know about the football. That's why I did not.
It has nothing
That's
to
why I
do
did
with
not know.
football. It has nothing to do with it.
That's why I did not
Doing your
understood the
minus
question.
sign. That's doing your minus sign. That's all.
No, I did not understood the question.
Yeah.
So next time in
Put
test,
problems.
yeah,
Okay,
put
okay, right. Okay, good deal.
You did say it was okay to send our papers in email, right?
You can, but I grade what I get. So if
Okay.
it comes out squirrely, I grade it squirrely.
Oh, no, it's been a little while, and I was just wondering if.
Oh, you have already sent it? Okay, I may have missed it. I'll be checking it then, to see. Okay.
So how do we know that we have to do the last part or not for that?
What's that again?
How do we know whether we have to do the last part
The last part.
of that problem? That where I get 200 something.
Oh, when you do the right answer, you plug that in and you would have gotten the right answer then.
You have some more graph papers?
I'm sorry?
You have any more graph papers?
Yes, I do. finding it an issue.
Thank you so much, sir.
All righty. Okay, I think I need to shut this down.